Hello, I'm Steve Easley, and welcome to the residential requirements of the 2006 International Energy Conservation Code for the state of Tennessee, the State Energy Office. Tennessee has adopted the 2006 IECC, or the International Energy Conservation Code, and the Energy Code is just one of the many codes in the family of codes from the International Codes Council. When you think about the mechanical code or the building code, these are all part of this family of I-codes, of which the Energy Code is one subset of that. What we're looking at here is a final inspection form, and when you look at this final inspection form, you'll see that there's a checkbox on here for the 2006 IECC. And basically what's required here is that we have to go through a series of checkpoints that determine whether or not a house is in compliance. Now, there's some big changes from this over the 2003 IECC. Number one, it's more stringent. There's definitely some differences, and they're somewhat small and local in format. But there are some completely new items. Number one, the whole climate base has changed. It's strictly geographical. It's not based on heating degree days like it was before. In the old format was like 19 different climate zones. So the new program has 8 climate zones, 2 of which are in Tennessee. So there's fewer zones and there's more homogeneity between the jurisdictions. There's better climate coverage of the zones since it's not based on heating degree days. And it makes a lot more sense. Instead of having 4 or 5 climate zones in Tennessee, we're down to just 2. So both residential and commercial use the same climate zones. Now, this is what the climate zones were like for the 2003 IECC. As you can see, when you look at the state of Tennessee, there's a number of different climate zones. And in fact, there were a total of 19 climate zones throughout the country. This has all now been changed, as I said, to 8 separate climate zones. And if you look at the state of Tennessee, what we're looking at for Tennessee is climate zones 3 and 4. Just a few counties in climate zone 3. Now, keep in mind that the climate zones are based on severity. So, for example, the climate zones start at zone 1, which if you look here, it's in the southern tip of Florida and even Hawaii. And then if you go all the way up to climate zone 8, that would be like Alaska. So as you can see here, that part of Tennessee is in climate zone 3, which is a fairly mild climate zone, and the other part of it is climate zone 4. The majority is in climate zone 4. There are roughly 14 counties that are in climate zone 3, and they're listed here. So what's changed since the 2003? Well, number one, the format is completely new. There are some really key differences, though. Single-family and multifamily buildings are now consolidated. The envelope requirements are independent of wall and window ratio areas, where it used to be that there were specific requirements regarding the ratio of windows to wall area that you could have. That's all gone. This change, though, does still allow you to use the performance method to take advantage of window wall ratios, but the prescriptive method does not. Performance path is much cleaner, it's more complete, it's closer to really being adapted more to a prescriptive method. And additions are much simpler as well. Now, some notable differences is that there are some new hard limits, or what we call trade-off limits, for glazing, which is for U factor and solar heat gain coefficient. So in other words, you can have some trade-offs, but there are limits as to how far you can go. The duct R value is R8, and that cannot be traded off. The prescriptive requirements are really pretty simple to understand. They're basically given an R value instead of U factors, so it's really comprehensible in the sense that when you look at floors, walls, ceilings, so forth, it's given by R values. So when you look in the chart, it says that walls are required to be R13. That's pretty easy to understand instead of trying to interpret U factors. And there is another requirement to seal the air handler and the furnace area. Ducts, air handlers, filter boxes, building cavities that are used as ducts must be sealed. So that's a change. So if we look at the structure of the 2000-2003 code versus the 2006, there's some notable changes there. When we start with the 2006 code, Chapter 1 is administration. Chapter 2 are definitions, which are really important to understand. Chapter 3 are the climate zones. Chapter 4 is the residential code, and that's broken down into general, building envelope, fenestration, and then simulated performance alternatives. And then Chapter 5 is commercial buildings, and that references ASHRAE 90.1, the 2004 version. The relationship between the IRC and the IEC is an important one to understand. Basically, the IEC addresses only energy. The IRC addresses all codes. And the advantage to this is that it does allow the builder to carry only one code book. And in the IRC, the International Residential Code, that basically has Chapter 11, which addresses energy, which is almost the same as the IECC, which is a separate energy code book. The IECC addresses both residential and commercial, and the IRC only recognizes residential and excludes most apartments. So the IRC references the IECC, so that's an important distinction to recognize. The energy requirements, as I mentioned, are almost identical between the two. There are some minor differences. The IRC has different hard limits for fenestration, and fenestration is just another term for glazing units. So there is a little bit difference between the hard limits there, and the IRC has no SHGC hard limit, and solar heat gain coefficient is what that term stands for. So when you hear the term SHGC, that stands for solar heat gain coefficient.